Assalamu alaikum. My name is Ridwan bin Monjur and I am presenting my PSM2 research project. My supervisor is Dr. Johanna Ahmad and she has helped me a lot to complete this research project. Complexity impacts upon the error proneness of software systems. So researchers have concluded that the complex areas of code should receive more attention during the testing phase, and they should be sought out using complexity metrics in TCP. Especially for testing event sequences in modern-day programs, it is unfeasible to test all events from such a large number of events, and therefore TCP technique is a solution to this problem. The previous research used the unique complexity metric. This research will use the modified cognitive complexity metric as it provides a more complete measure of complexity for OP-based modern programs. Software complexity is a difficulty in analyzing, maintaining, testing, designing, and modifying software. There is a relationship between software development error and complexity. Complexity has become one of the factors that has been agreed by researchers to influence the effectiveness in detecting faults and thereby be used in TCP. UCM was found to be the most popular metric in the previous research. Therefore, it was used in a 6-weight value in the 6-factor multi-factor weighted approach of TCP, which eventually proves to be successful. The unique cognitive complexity considers many factors of procedural complexity, such as lines of code, sum of operators and operands, and the weight to basic control structure (BCS). However, it suffers from some limitations, which is overcome by the MCCM metric. Firstly, the MCCM metric measures the object-oriented nature of programs. Secondly, it gives a weighting to the nesting of basic control structures. The research methodology of the framework is composed of 4 phases. Phase 1 is literature review, Phase 2 is problem definition, Phase 3 is experiment evaluation. The Phase 1 and Phase 2 has been done in PSM1. Phase 3 and Phase 4 will be done in PSM2. Mutation testing is one of the most popular methods for evaluating TCP. Mutants are simple and common programming errors to make a test suite fail and assess the quality of a particular test suite. If the test cases do not fail due to injected mutations, it indicates software test cases are not able to test part of the code that contains mutations. Gesture mutation tool. This tool is used to carry out automated mutation testing. It is very easy to use and learn, as was the experiment of us during conducting this research. So now I will present the experimental setup. The first step is mutations are chosen and configured in a gesture. Then the mutation testing is executed in the gesture tool. The second step is results are recorded in the fault matrix. The third step is the UCM and MCCM metric values of the methods and test cases are calculated. The fourth step is the fault matrix is reordered based on test cases complexity values, and the APFD of the reordered fault matrix is calculated. So gesture configuration file mutations.cfg is configured. Here we can observe 6 mutation operators. First, 0 is changed to 1, 1 is changed to 2, 2 is changed to false, and vice versa. The if loop is tampered with to make it fail, or to make it false in some cases at all times and true in some cases at all times. Plus plus is changed to minus minus and vice versa. Equals to is changed to not equals to and vice versa. The gesture tool is run from the command line M tool. 24 mittens are produced from 32 cases for the circular queue program. 26 mittens are produced for 39 test cases of the bank program. The results are recorded in a fault matrix table. As we can see, UCM also only measured the procedural complexity, which is lines of code, basic control structure, which are the flow controls, and loops like for loop and while loop, and for flow control, that is the if conditional, and the sum of operators and operands. The MCCM metric measures the procedural aspects such as effective lines of code and wait for type and nesting of basic console structure. The object-oriented aspect of the MCCM metric measures the weight due to coupling and cohesion, weight due to encapsulation, weight due to inheritance. The fault matrix is reordered due to the complexity values. Methods complexity are used to construct test cases complexity. For example, for test case T1, it is made up of add, uh, the parameter is 1, circular queue, and then there is another add method with parameter 4, and remove. So for this, we will say that the test cases value is the sum of the complexity values of the methods themselves. So the sum of the methods complexity here is 2 into 46 plus 42, resulting in a test case complexity value of 134. Test cases are ranked in order of their complexity. Higher complexity value test cases are ranked first. So in this experiment, we can see that the test case 27 has been ranked the first. However, the first test case 1, it has the lowest complexity value, so it has been ranked the last. The APFD is one of the most popular metrics for evaluating TCP. The formula of TCP APFD has been given here. It identifies how effectively a test suite identifies faults. For circular queue and a bank program, the APFD calculations have been given. The same with MCCM program. We observe for both programs the MCCM value is higher than UCM's. There is a difference in APFD between UCM and MCCM for circular queue program. So for MCCM, we observe that the add and remove method are nearly same, are the same value, but it is higher value for the UCM's matrix add method. And we also observe that the values in the MCCM metric are quite close to each other. 1.47 is quite close to 1.3. However, in case of UCM metric, we observe the last value is much smaller. So the method front is much smaller than the method front's UCM value is much smaller than the method values of the topmost two methods, add and remove. There is also a difference in APFD in UCM and MCCM for the bank program. So this is due to two reasons. The number one reason is not all methods have the same ranking. Some methods have higher ranking in UCM but lower ranking in MCCM. The number two reason is half of the methods, deposit, withdraw, bank, and inquiry, had four methods actually had UCM values lesser than 50% of the maximum UCM value. However, only one method had a MCCM value lesser than 50% of the maximum MCCM value, which is 1.23 units. So in conclusion, both the PFD values of the MCCM based TCP came out higher because MCCM metric measured the object-oriented nature of the programs. So it measures the program's methods and test cases complexity values much differently. The reordering was more successful, so TCP by MCCM was more successful. The evaluation, however, in hindsight, we observed the experiment did suffer from some limitations. The program samples are comparatively small and just two in number. Moreover, there was no instance of inheritance of in the program which was given a weight by the authors of the MCCM metric. Further work should focus on applying object-oriented metrics on sample programs and finding a more effective metric for object-oriented programs. So that concludes my presentation for my uh, also concluded PSM project. So firstly and foremostly, I would like to thank Allah the Almighty for helping me to complete this research paper. I would also thank my supervisor, Dr. Johanna, for her endless support, uh, kindness, compassion, and help, without which I would have never been able to complete the project. And I'd also like to thank my evaluators for giving me the opportunity to correct my project during PSM1 and helping me to improve uh, in helping me to improve in uh, conducting a research project successfully. With that, I would like to conclude.